Welcome to Vishesh Educational Videos. In this video, I'm explaining about POSIX.1b timers. If you are not subscribed to my channel, please subscribe to my channel. To get the notification of my new videos, please click the bell icon. And please don't forget to like the video and please don't forget to share the video with your friends. So let me begin the explanation of POSIX.1b timers. So POSIX.1b defines a set of APIs for interval timer manipulation. Timer, why it is used? Timer is mainly used to set the timer for particular interval. For example, by using the timer I can set a time for 5 seconds. Interval. What is the interval? Interval is between 1 to 5 seconds. So if I set a time using a timer for 5 seconds, and the interval will be from 1 to 5 seconds. Hope you are understanding now. Right? So POSIX.1b defines a API for interval timer manipulation. You can use POSIX.1b APIs to change the interval values of a particular timer. By using a timer, I can check the value interval. Time interval. Time interval means, for example, from 1 second to 10 seconds. Like that, I can use a timer to set the interval, right? Interval of time. Okay? The POSIX.1b timers are more flexible. So what is the advantage of POSIX.1b timers? So POSIX.1b timers are more flexible and powerful than Unix timers. Why? What is the reason? So user may define multiple independent timers for system clock. The best advantage here is in POSIX.1b timers, you can define multiple timers per system clock. You can use multiple timers, right? Independent multiple timers simultaneously, right? And the timer measurement, the timer resolution can be set in nanoseconds. That is also possible if you use POSIX.1b timers. And also, user may specify, right, on a timer basis, the signal to be raised when the timer expires. Right? So another advantage is when a timer expires, right, the signal we have to send, the signal will be sent to the user that it is telling that the user that timer expired, right? In simple words, so signal will be sent to the user when the timer expires, right? And the timer interval may be specified as either an absolute or relative time. That means using the timer I can specify the interval, fixed value. Absolute value means interval can be specified as a fixed value, or else I can set the relative time. Relative time means changes to the time. You can specify the changes in time also. That is the relative time. Absolute value means time is fixed. So you can specify both absolute and relative time, right, in POSIX.1b timers. Hope you are understanding. Suppose if you have any doubts, please post your doubts in the comment section, right? And there is a limit on how many POSIX timers can be created per process. That means, yes, you know that in the main advantage of POSIX timer is I can create multiple timers, multiple independent timers. But how many multiple timers you can create at a time? So that constant, that value, that how many timers you can create, multiple timers you can create at a time, that is defined in a constant timer max. If you see that constant, it will tell that how many multiple timers can be created in POSIX.1b timers. And also this timer max constant is defined in the header file limits.h, right? And POSIX timers created by a process are not inherited by its child process. Right? Main difference. POSIX timers created by a process are not inherited by its child process. So POSIX timers right, is going to be used by only the parent processes. The process that is created the timer, it is going to be used by only the parent processes. The child processes are not going to use the timer that is created by the parent process, right? But the timers are retained across the execute system call, right? But uh, understand that timers are not going to be used by the child process, right? Only the process that created the timer is going to use the timer. Next, a POSIX.1 timer does not use the SIG alarm signal when it expires, right? You know that why we have to use SIG alarm signal, right? When alarm to send the alarm to the process when the particular time interval expires, I have to send the signal, right? So that SIG alarm signal is not going to be used by the POSIX.1 timer when it expires. It can be used safely with the sleep API in the same program. Hope you're understanding. I can use sleep API, right? And the POSIX.1b API for timer manipulations are, suppose if you want to change the timer values, the POSIX.1b APIs, what are the POSIX.1b APIs you can use? Means you can see here the timer create API. You can see the program here, it's a simple program. Here you are using a function timer create. So their arguments are there in the timer create function. What are the arguments? Clock ID, clock value, clock ID underscore t means it's a derived data type. So it is clock is there, that is the argument. Next, signal event is another argument. Next, timer is also another argument. You can see here the timer create API is used to dynamically create a timer. First of all, to create a timer, you are going to use the API called timer create. You can see here, right? Timer create API is used to dynamically create a timer. When you create a timer, it returns the handler, because you know that even when you create a multiple timers, you have to use separate handler for separate timers. Handler is nothing but it's like an address of a timer, right? Next, what is the second argument? You can see here the clock argument is there. So clock argument specifies which system clock would be the new timer based on its value. Understanding? The clock argument specify which system clock would be the new timer, right? Which you can tell that which system clock could be your new timer based on its value. For example, maybe clock real time for creating a real time clock timer. This is defined by POSIX.1b, right? So hope you are understanding. The clock argument specify which system clock could be the new timer based on its value. It is going to, if there are multiple system clocks are supported, you can use the clock argument to tell which would be which system clock you are going to use for the new timer, right? Hope you are understanding, right? Next, what is the third argument? The specific argument. What is that? Spec. The spec argument defines what action to take when the timer expires. Obviously, when the particular interval of time expires, for example, if a time is between 1 to 5 seconds, after the 5 seconds, you need to take some action, right? Like that. The specification argument defines what action to take when the timer expires. And the SIG event, you can see here, SIG event is there, signal event. It is simple words, it is a signal event. The structure signal event data type is defined as, you can see there, signal event is a structure. It contains different data types. So why I am using a signal event here in a timer create means, you can see there, why I am using a signal event means, see what are the data, different types of data we are going to define in the structure signal event means, signal event notify, signal event signal number, and signal event value, right? So this structure contains the different right fields. So I'm going to explain this. The sig event signal number field specify a signal number to be raised at the timer expiration. It is valid only when the sig event notify field is set to sig event signal. Don't get confused here. In simple words, the sig event signal number field specify the signal number. In a simple words, it is going to contain a signal number. It is going to tell which signal you have to raise when the timer is going to expire, right? And what more important condition here is, it is going to be valid only when the signal event notify field is set to signal event signal. Then only it will notify that which signal number to be raised at the timer expiration. When the timer is expired, it is going to tell which signal you have to call, right? And if the signal event notify field is set to signal event 10, no signal is raised by the timer when it expires. Very important. When the signal event notify field is set to signal event none, that means when timer expires, you are going to set the value to the none. None means it is not going to take any action. No signal is sent to the user that telling that the timer is expired. No, nothing will be sent to the user. No signal will be sent to the user if the sig event notify field is set to sig event none. Right? When the timer expires, no signal will be sent to the user to notify that. Hope you are understanding. Right? Now, because multiple timers may generate the same signal, the sig event value field is used to contain any user defined data to identify the signal that is raised by a specific timer. Very simple. You know that multiple timers are supported in your POSIX.1b timers. Suppose 2 or 3 timers sent a same signal, then there will be a problem. That's why to identify which signal is sent by the which timer, because for example, assume that sig alarm signal is sent by the 3 timers. So 3 timers is sending the same signal, sig alarm. At that time there will be a problem. So that's why what I am going to use, I am going to use sig event value field. Right? What it contains? Sig event value field used to contain a user defined data to identify that a signal is raised by the specific timer. You can see there the sig event field, what it contains. You can see there the signal value, right? You can see there the signal value contains signal value and also pointer to that value. Hope you are understanding. So if you want to identify that particular signal, same signal that is sent by the multiple timers, if you want to find out which signal belongs to which timer, you can do that using the sig event value which contains some user related data. User can specify his own data, thereby I can identify which signal is for which timer. I can include my own particular user defined data, my own data. Based on that I can identify the signal. Hope you are understanding. So you can see there that value. So in that signal event value field only I have to specify the user related data, right? How I can specify that means, you can specify that value in the signal value underscore integer variable. You can specify the data. Based on that I can identify the signal for different signals, that is for different timers. And also you have a pointer. So pointer, right? Why we have a pointer? Pointer holds the address of that particular value. That's why. Hope you are understanding. Right? If you have any doubts, please post your doubts in the comment section. For example, see here, a process may assign each timer a unique integer ID assigned to the sig event value. You can see there process may assign each timer a unique integer ID. For example, if a process wants to identify the timer, how it can identify? A process is going to identify the particular timer in the group of other timers. How it can do that means by using the integer ID, unique integer ID. Hope you are understanding. Right? Next, to pass this data along with a signal, when it is right, the SA underscore SIGINFO flag should be set in a SIG action call, which sets up the handling for the signal, and the handling function prototype should be like this. So very simple, don't get confused here. To pass this data along with the signal, which data? Right? Particular integer data, unique integer ID for each timer, right? So that if you want to send this particular unique integer ID with a signal, how you can do that is you can use a flag called signal information flag. It contains, right, that particular integer ID details, and it's going to be set in a signal action call, because you know that for every signal the action should be taken. 3 actions can be taken, you know that. Either you can take a either you can ignore a signal, like either you can take a default action, or else you can take action based on the user function. So right, so you can send this particular data in a SIGINFO flag. Based on that, right, the data can be used in when a SIG action function is called. Right, you can see there for every signal there should be a handling function, right? You can see here signal handler function contains signal info, right, and also uContext. For example, when the signal handler is called, the EVP SI value contains the data of the SIG value. The SIG info data type is defined in siginfo.h. I don't want to confuse you guys. You can see there the SIG info field contains the particular data, integer ID data, right? You can see here the particular integer ID data will be there in the SIGINFO field. You can send that SIGINFO field, you can send the data with the signal handler using the SIGINFO flag. Hope you are understanding. I don't want to confuse you guys. Right? In a simple words, when the signal handler is called, that particular EVP contains the data of the signal value. The SIGINFO data type is defined in the siginfo.h header. You can see here EVP. EVP, what it contains? This EVP contains, right, the data of the SIG event value, and also along with that SIGINFO data type is defined in siginfo.h. And one more important thing, if specification is set to null and the timer is based on the clock real time, the SIG alarm signal is raised when the timer is expired. When the timer expired, if you want to send a SIG alarm signal, the specification is set to null. The specification value should be set to null. Hope you are understanding. Finally, the timer STRP argument, right? You can see here, don't get confused here. Specific timer, you know that to send the SIG alarm signal you are going to use this. Next, timer STRP, why you are going to use it means the timer STRP argument, right? So that is the last argument here, the timer STRP argument, right? So it is going to hold the handler of the newly generated timer. When you create the timer, you can see here. So you are creating the timer here. So when you are creating the timer, right, you have to hold the handler of the newly generated timer. Why you need the handler means mainly to identify the timer. So this timer STRP argument is an address of a timer underscore t typed variable. So and it is going to hold the handler of the newly generated timer. For every timer there will be a handler. So based on the handler only, right, you can call other POSIX timers, and they should not be null. The strp argument value should not be null. Based on that handler value only, you can call other timer APIs, right? So this handler will be like address. So these APIs, based on that handler, it can identify that particular timer, right? Hope you're understanding. And whatever the functions, whatever the API you are using here, the create, set time, get time, so these functions is going to return right 0 on success, and if these functions fail, they will return -1. And you can see here I've used set time and get time. Why I used, right, the timer set time is mainly used to start and stop the timer. You can start and stop a timer using the function timer underscore set time, and the timer get time is used to query the values of the timer. If you want to if you want to know what is the correct value of your timer, you can fetch that values using the API timer get time, right? And you can see here, so this is the timer specification data type. So where I used here, here you can see I used right a structure timer specification. Why I used, what it contains, you can see timer specification I've used here. Why I used this, while setting the time I used this, right? Why I used this, you can see here. So this struct timer spec, it is struct timer spec data type contains two right value. The timer spec value specify the timer remaining in the timer. So this one is going to tell the remaining time. This second one is going to tell the remaining value of a timer, how many seconds or nanoseconds remaining, right? And also this time interval, timer underscore interval specify the new timer reload the timer when it expires. If you want to tell, right, if you want to tell to reload the timer when it expires, how you are going to tell that with using this interval value that is specified in this first statement. If you want to reload your timer, how you are going to do that? When you have to reload the timer, that value is defined in the interval, right? Hope you are understanding. Next, you can see there, so whatever the values that you are going to define for the timer will be like, for example, the times can be specified, the times can be specified in seconds, or the time measurements can be specified in nanosecond. You can see there. If you want to specify your timer interval in seconds, you can use this. Suppose if you want to specify your timer values in nanosecond, you can use this. Hope you are understanding, right? And the flag parameter in timer set time. So this one, which one? The flag parameter. The flag parameter. You can see here the flag parameter. So here, one second. Yeah, the flag parameter in the timer set time. Why you use that flag, right? The flag parameter in timer is maybe 0 or timer real time. If the timer start time is relative to the current time, the flag parameter value may be 0, or else it is a timer underscore real time. Real time means mainly to set the real time timer. Real time means, right, you know that real time clock, right? If the timer start time is relative to the current time, hope you are understanding, right? And if the flag value is timer absolute time, the timer start time is absolute time. Earlier in this video I explained about real relative time and the absolute time, right? So to tell that whether your time is fixed you can use this one. If your timer is relative, that is real time, it is not fixed based on the right run time. You can fix your time, right? That is why real time. Hope you understand. This flag meter is parameter is going to tell whether your time is a relative time or a absolute time. Hope you are understanding, right? And one more function is there, the get overrun API. You can see the get overrun API. What is the use of this function? The timer underscore get overrun API returns the number of signals generated by a timer, but was last. Overrun means last. It is going to tell that if you want to know which are the number of signals that is generated by a timer, but they are last, you can do that using a timer get overrun. And one more important thing, timer signals are not queued by the kernel if they are raised, but not processed by target process. So timer, whatever the signals of the timer, so that signals are not queued by the kernel if they are raised but not processed by target processes. If they are processed, it will be queued, otherwise, right? If they are not processed, it won't be queued, right? And why we use timer destroy or timer delete? Obviously, as the name suggests, the timer destroy is used to destroy a timer created by the timer create API. You can see here, if you want to delete whatever the timer you have created using a timer create, you can delete the timer using this, or you can destroy your timer using this, right guys? So hope you understood the concepts. Suppose if you have any doubts, please post your doubts in the comment section. Thank you for watching the video.